Welcome to Algebra 2, Semester 1, Unit 4, Section 4.7. This morning, what we're going to be working on is using algebra tiles to complete the square. You remember from Algebra 1 first semester, hopefully, that this large tile represents x squared, and that these long skinny ones represent x. So, let me get my long skinny ones over here. So, if we have x squared plus 6x, there would be x squared plus 1x, 2x, 3x, 4x, 5x, and 6x. So take a minute right now to draw that rectangle with the 6 x's and the x squared in this first box. Okay, so I'll show you in my notes. This is how I drew mine. I just drew it showing it in that way. Now the next box, we're asked to start making this into a square. In order to make it into the square, it's easiest to split your x's in half and put them on each side of that large square. So in your next box, go ahead and circle, or go ahead and draw that shape showing that it's x squared plus 3x plus 3x. Now, in the final square, what we're doing is we're completing this square. This is what this activity is called, and it's really useful in math, is to complete the square. We're going to bring in small, we call these just value of 1, it's an integer of 1, and we complete it. Now you can probably already picture how many of these it's going to take, so you could start drawing it. But to complete this square, we had x squared plus 6x. We split the 6 into a 3x and 3x, which created a 3 by 3 little corner here that we had to fill in with integers. So now our completed square equation is like this, drawn on the paper, and it is x squared plus 6x. We took that 6x, divided it in 2, we got 3. 3 squared is 9. We get that little square of 9. Okay? So, turn the page. Again, if you have to pause the video to draw these, please do so. The next one, we're asked to model an x squared plus 2x. There's our x squared. And there's our 2x. A little bit less time drawing that one. And so when you draw it, make sure and draw the rectangle that we have and write x squared plus 2x. Now the next thing we're going to do is we're going to split that x's in half so that we end up with an x squared and an x on each side. We write that as x squared plus x plus x. And now in order to complete that square in your final little box there to draw, all you have to do is add one integer. And how I drew that was showing the box, the x's, the x squared, and the little one integer there. And it's written as x squared plus 2x plus 1. Now it's real important that you see where we get that 1. So make sure to take this middle number, divide it by 2, and square it to show that you're getting the 1. Next one. Make sure you're pausing the video as you need to. We're asked to model x squared plus 4x. So, you can move ahead without me if you'd like. To model that, we have our x squared plus 4x. Now, on the next drawing, we're going to show x squared plus 2x plus 2x. And then in our final drawing, we show how we complete this square by adding 4 integers right there, just 4. So it becomes x squared plus 4x plus 4. And how we get that 4? If you're building it, you just fill in the square. If you're not building it, you take this middle number, divide by 2, and square that. 4 divided by 2 is 2. Squared is 4. So that's how we complete the square. Next one, x squared plus 8x. I don't think that I have enough pieces, so I'll show you how I drew it. It is x squared plus 8x. Now we split them. How many would be on each side? Well, that would be x squared plus 4x plus 4x. So when we complete the square, it looks like this. We had a 4 by 4. 4 times 4 is 16. Another way to get it is to say x squared plus 8x. We take that middle term, divide it by 2. That would equal 4. And now we square that. When you square that, that equals a 16. Notice these are always positive because any number squared is going to be positive, any real number squared. Last one, we can't even show with tiles, so I'll just show you how I drew it. We have x squared plus x. Now, what we have to do is we have to split that 1x into halves. So we have x squared plus half x plus half x. So we take that 1/2 and square it, we get 1/4. So we have x squared plus 1x, because they are a total of 1x, plus 1/4. Because that would just be a fourth of a tile right there that's a half by a half. Half times a half is a fourth. Okay. So that brings us to the end of completing squares. Now let's go into solving equations by completing squares. First thing we're going to do is just practice completing the square without the tile. So if we had x squared plus 14x, we'd be splitting that 14x in half. That would be 7. And then we square it. That would equal 49. So our C value is 49. Next one, we take our middle term, 22, and we cut it in half. 22 divided by 2 equals 11. Now we take that 11, we square it, and we find that our C value is 121. Okay, next one, we take our 9, we cut it in half. That's not going to come out real nice and even, so I just leave it as a fraction and go ahead and square it. Because we know from exponents that that becomes 9 squared over 2 squared. So that would be 81 over 4. And you can leave it as 81 over 4, or if you want to go ahead and break it into a mixed number, just divide 4 into 81. It'll go 20 times with 1/4 left over. So you could have 20.25 or 20 1/4, or you could leave it just as the 81/4. All of those are correct. Okay, so now we're going to solve problems using this new technique. So we want to find out what x is equal to. Notice this already is a perfect square, because if we divide 8, we get 4. 4 squared is 16. So we know that the square, if we go along the side, is x minus, we bring that minus in here, 4 squared. Now let me just review how we got that. If you look back at your squares that you drew, the way that you get that is if you just go right along the side. This is x. The length here is x, and the length there is 1. So it's x plus 1 times x plus 1. This one being x squared plus 4x plus 4. If we go along the side, the length here is x plus 2 times x plus 2. So mathematically, all that you need to do is take the square root of this one, square root of this one, and the sine of the middle one, and then just show that it's squared, that it's a perfect square. Equals 25. Now we want to get that x alone, so we take the square root of this side, x minus 4 squared, equals 25. And what we do to one side, we have to do to the other, so we take the square root of that. We end up the square root and the square cancel. We have x minus 4 equals plus or minus 5, because that could be positive 5 times positive 5, or it could be negative 5 times negative 5. So now we add 4 to each side. That one wipes out. And we have two possible answers here. Remember, because we have a degree of 2, we're going to have two answers. So we could have x equals 5 plus 4 would be 9, or negative 5 plus 4 would be negative 1. So either of those answers. Next one. This is a perfect square because half of 6 is 3. 3 squared is 9. So we go ahead and we write x plus 3. Again, we took the root of the first one, root of the last one, and the sine of the middle one. Okay. We take the square root of each side, and we find that x plus 3 equals plus or minus 6. Subtract 3 from each side. We get x equals, well, 6 minus 3 is 3. And then our other choice is negative 6 minus 3 is negative 9. Now, if you want to check those, you just plug that 3 or that negative 9 right back into the equation and it will come out true. And I will probably ask you to check a few tomorrow to make sure that you see how to check it. We're kind of out of room on this page to do that. Okay, again, we look at this. Half of 10 is 5. 5 squared is 25, so we have a perfect square. X minus 5 squared equals 1. Take the square root of each side. We get x minus 5 equals plus or minus 1. Now we add 5 to each side. Get that x alone. Remember, that's always our goal. So we have x equals 1 plus 5 is 6, or negative 1 plus 5 is 4. Okay, next one. Half of 24 is 12. 12 squared is 144. So we have x minus 12 squared equals 100. Now we take the square root of each side, and we end up with x minus 12 equals plus or minus 10. Now we add 12 to each side, and we finally have x alone because that wipes out. 10 plus 12 is 22, or negative 10 plus 12 is 2. Okay. We're going to do just a few more here. We'll get into some variety. Keep rewinding the tape and watching if you need to. Now, when we look at this one, half of 12 is 6. 6 squared is 36, so that's not set up. Oops, I'm sorry, I didn't notice I was off there. There we go. So half of 12 is 6, and 6 squared is 36, so we are not with a perfect square. So what we do is we subtract that 4 to get it to the other side. And now we have x squared minus 12x, and then I leave a blank here because I'm going to fill in what I want, equals negative 4, and I'm going to leave a blank here because I'm going to fill in the same thing over there. Half of 12 is 6. 6 squared is 36. And now we take the side of that square, which is x, this sign, minus 36, root of that would be 6. We square it, equals negative 4 plus 36 is 32. So now we take the square root of each side, and we have x minus 6 equals plus or minus square root of 32. Now we're still trying to get that x alone. Just focus on that for a minute. We need to add 6 to each side. Well, you know from our radical practice, you can't add a whole number to a radical. As far as getting just one final answer, you can still add it, but you write it out. So it becomes 6 plus or minus radical 32. Now, why would I not get full credit for this answer? If you said it's because I have prisoners left underneath that radical, you're exactly right. I need to come over, take that radical 32, break it down. 8 and 4. 2 and 2. And 8 breaks down to 2 and 4. The 4 breaks down to 2 and 2. So, radical 32 becomes 2 times 2 times 2 times 2 times 2. I know that I'll have some left in prison, so I'll build the prison. But these two will get out. Those two will get out. Put a times between them. Only one of them has to stay in. Okay? 2 times 2 is 4, and then radical 2. So my final answer should be x equals 6 plus or minus 4 radical 2. Okay? Let's try this again. Now, the complete a square will not work if you have 2 in your leading coefficient. It has to be a 1 with that x squared. So the first thing we do is we divide 2 out of everything in the whole equation. So 2, 2, 2, 2. Divide everything by 2. And then we'll come up with an equal equation, but we'll just have that factor gone. So we have x squared plus 4x plus 7 equals 0. Now, we subtract 7 from each side because that is not going to complete that square. So we have x squared plus 4x plus, leave a blank there, equals negative 7 plus. Now we ask ourselves, half of 4 is 2, squared is 4. So we add 4 to each side. Now, we write the side of that square. It's x, the sign from the middle one, the root of the last one, and we square it. Equals negative 7 plus 4 is negative 3. Now, we take the root of each side. I've got to look how we do it in this class because my other class. Okay, at this point, when you see that it's the square root of a negative number, I just want you to go ahead and write no real number solution. And I don't make you go any further until you get to Algebra 2. Okay? So just realize that won't be a real number because you can't get a number to multiply by itself basically and get that negative. Okay? Okay, over to this next one. Half of 6 is 3. 3 squared is 9, so we need to have this be, subtract 4 from each side. We have x squared plus 6x plus 9 equals negative 4 plus 9. Okay? Now this becomes x plus 3 squared equals negative 4 plus 9 is 5. We take the root of each side. We now have x plus 3 equals plus or minus radical 5. Now we just subtract 3 from each side. So we end up with x equals negative 3 plus or minus radical 5. Okay, want to do one on this side. Again, we can't do these with the leading coefficient not being 1, so we have to divide everything by 3. If it doesn't work to divide by whatever that factor is, then you cannot do completing the square on that problem. So this becomes x squared plus 4x minus 6 equals 0. We know half of 4 is 2. 2 squared is 4, so we need to move that 6 out of there. X squared plus 4x plus, we'll put in the 4 in a minute, and now we've added 6 to each side, so we have 6 over here plus. Okay, we said it was a plus 4. Now we take the root of that square, x plus 2 squared, equals 10. Take the square root of each side, and we get x plus 2 equals let's see, I just had another thought on a problem that I just did for you guys. Radical 10 plus or minus, and now we subtract 2 from each side, x equals negative 2 plus or minus root 10. Okay, new thought that just hit me. You are in Algebra 2, so we don't stop this last one at this point. You just completed a section on complex numbers. You guys were probably laughing at me. I do so many of these tapes, I forgot which class I was in. Okay, so when we get to here, we go ahead and we clear out that. We have x plus 2 equals plus or minus, we can pull out that negative. Remember, it's our imaginary unit, I, radical 3. Now we have x equals, subtract 2 from each side, negative 2, plus or minus, I, radical 3. Okay, class is going to be starting. So I'm going to just put in the answers. If you cannot get these, then see me. The answer to this one ends up being x equals 5 plus or minus radical 17. The answer to this one is n equals 1 plus or minus 2 radical 2. So do these before the bookwork. This one ends up, what you have to do is divide each side by 6. You'll get x times x plus 8 equals 2. Then go ahead and distribute this out. X squared plus 8x plus, and then you'll fill in what the completing the square is there. 2 plus, complete the square. And your final answer for that one will be x equals negative 4 plus or minus 3 radical 2. The final answer for the bottom one here is p equals 1 plus or minus radical 26. Okay? So if you can't get these final answers, then make sure and see me in class and we'll work through them. Thank you very much. Have a good night.